Hi everyone, let's continue with sp3d hybrid. sp3d hybridization is a mixture of s3p orbital and 1d orbital. So it will result as sp3d hybrid orbital, and you will have 5 of them. And this will adopt the trigonal bipyramidal geometry. And you will have, if there's no lone pair, there will be two angles, 90 degree and 120 degree. Let's look at the example of PCl5, and this is the Lewis structure for PCl5, and here you can see there are 5 sigma bond here. For phosphorus, if you want to form 5 sigma bond, means you need to have 5 single electron. But then, for the ground state of phosphorus, you will just have 1 to 5 valence electron. But this electron here, you can see, it is in pairing of electron. Therefore, for this electron, okay, since you don't have any lone pair there, so one of the electron will be excited into this empty. This is the empty d orbital. Okay, walaupun tiada electron here, but the existence of this orbital is there. Okay, so remember balik apa yang kita pernah belajar before this, expanded octet. Okay, the d orbital is there, but it is not filled with electron. It is for period 3 and above. More than 3 lah. There is the presence of the d orbital. Therefore here, at the excited state, you will get this as 5 single electron, and they are ready to form 5 sigma bond when you hybrid all of this. Okay, so you need to hybrid all these 5 of this orbital, so you will get them as sp3d. Okay, so it's either you write each and every orbital the new name, or you can write it in this way, which is you just do the curly bracket here and then sp3d. So means you don't need to write each and every one of this lah. Okay, and you can see this part, the empty d orbital here, you will write them as 3d unhybridized orbital. Okay, so separate them into half. Okay, as the hybrid orbital and the unhybrid orbital. So the Lewis structure will be this, and you will have 5 sigma bond. Okay, the bonding pair of electron will be 5 and 0 lone pair. The total electron pair will be 5, therefore the hybrid will be sp3d hybrid, and the class will be AB5. Okay, therefore your hybrid sp3d will adopt the shape of trigonal bipyramidal. Okay, so means when you draw in step 4 later, you will use this as your guideline to draw. Okay, next. Okay, by referring to your Lewis structure, so you know that phosphorus here should be sp3d hybrid. and your orbital diagram for phosphorus, and make sure you know the valence electron for phosphorus. It will be in 3s in period 3, so it will start from 3s2 and 3p5, and there are presence of this empty d orbital. You have this empty d orbital here. Okay, what's the function of this empty d orbital? So your one electron here will be excited into this empty orbital. Okay, because you need to form 5 sigma bond. Okay, so you need to have 5 single electron. So now at excited state, you have 5 single electron, and for hybrid state, you will form 5, 1, 2, 3, 4, 5, and all of them are sp3d hybrid. 1, 2, 3, 4, 5, and the rest of this will be 1, 2, 3, 4, 3d unhybrid orbital. Okay, so for the terminal atom, you have chlorine as a terminal atom, and it will be 3s2, 3p5. Okay, and you have here single electron for the formation of sigma bond, and you have 5 chlorine here. Okay, and double check your hybrid state of phosphorus. 1, 2, 3, 4, 5. So each of the single electron in phosphorus sp3d hybrid orbital will overlap with 3p, one single electron in 3p orbital. Okay, so these two here label sp3d orbital for phosphorus hybrid orbital, and for untuk chlorine it will be 3p orbital when you draw later. Okay, so you will come to this drawing and make sure you draw this according to your geometry just now kita predict. It will adopt trigonal bipyramidal. Okay, so make sure you label the atom and each of the orbital here. So for phosphorus, you have sp3d hybrid orbital, and each of them has one single electron. Okay. So for chlorine, make sure you label them as 3p orbital. Okay, because the single electron is from 3p orbital. Okay, so when you draw the overlapping, make sure to label this sigma bond at each overlapping. Okay, di sebelah kamu buat overlapping of the electron. Okay, and then state the class. Okay, based on the drawing here, it should be A, B5 because there are no lone pair. And the geometry will be the same, trigonal bipyramidal. And the bond angle will be 90 degree and 120 degree. So double check with your Lewis structure. It should be trigonal bipyramidal. Okay, next. Let's look at the example of BRF3. So here you have the Lewis structure of BRF3. So if you need more time to draw the Lewis structure, pause this video first and do it step by step. Okay, later when you already have the Lewis structure, make sure you draw in this form. because you want to draw it. It is not exactly, but almost similar to the trigonal bipyramidal punya shape, basic shape. Okay, if you can see from the drawing, dia akan seakan-akan T shape. Okay, so when you want to predict the hybrid of the central atom, okay, so tengok BR, you have 3 bonding pair, 1 sigma, 2, 3. And for the bonding pair, kamu hanya consider sigma bond sahaja. And then lone pair for bromine, you have 2 and the total will be 5. And for the hybrid, it will be, so total ada 5 kan, so dia akan jadi sp3d hybrid. So total S tambah P. Okay, so the total will be 5 sp3d hybrid. Okay, so hybridnya adalah yang inilah. And then the class will be AB5 ataupun you can straight away write AB3E2. Okay, tapi it's okay, later bila step akhir sekali kita akan state semula the class according to the geometry that we draw dekat step 4. And kalau untuk predict, okay, kita nak predict dia akan ikut the basic shape, which is the electron pair geometry, akan ikut trigonal bipyramidal. Okay, the third step is orbital diagram, and remember ini hanyalah untuk valence electron. Okay, so untuk bromine, since dia adalah di period, bromine is in period 4, so the valence electron will start from 4s2, 4p, 1, 2, 3, 4, 5. Okay, so look at your Lewis structure here. You need to have 1, 2, 3 sigma bond, and there are 2 lone pair. Okay, so means dekat ground state ni, just double check your structure, your orbital diagram. So means sini kena ada lone pair sepasang, 2 pasang lone pair, and you need to have 3 single electron for formation of sigma bond. But then you have here as pair. So means dekat sini yang paling hujung ni kamu akan excite dia masuk dalam the empty. This is the empty d orbital. Okay, so for the next step, the excited state kamu akan dapat in this form. 2 elektron sebagai pair, and you will have 3 single electron. Therefore, dekat sini kita dah predict just now, untuk bromine, dia akan sp3d hybrid. So means you will hybrid. So you will hybrid all of the orbital sp, p. So here 1, 2, 3, 4, 5 sp3d. Lone pair, sigma, sigma, sigma. And the rest of them, 4 ini akan jadi 4d unhybrid orbital. Okay, tulis je yang ini. So, for bromine dah settle lah. And kalau kamu nak double check, boleh juga. So here you have lone pair, sigma, sigma, sigma. Okay. And next, the ground state of phosphorus is 2s2, 2p5. And then you have 1 single electron here untuk buat overlapping to form the sigma bond. Okay, so you will come to the fourth step, which is draw and show the overlapping of sigma bond. So make sure you label each of the orbital, and for the bromine atom, it must be sp3d, sp3d for each of the orbital, and for fluorine, it will be 2p orbital. And don't forget to label the sigma bond here. So your sigma bond, make sure you label them right next to the overlapping of the sigma bond. And then the last step is you need to state according to this drawing. And the class will be AB3, E2 because you have here lone pair. You need to consider the lone pair. And then the molecular geometry will be T-shape, and the bond angle will be 90 degree. It's between the bond. So you can see in between here, it is between bromine dengan fluorine, bond between these two with another bromine fluorine punya bond. So the bond angle will be less than 90 degree because you have two lone pair, and lone pair repulsion is quite big, so dia akan menolak all the bonding pair will be smaller.